Hey guys, welcome back to another video. It's been a while since I've done any house lighting ESP controlled video, so I thought I'd start another project in that. I still have to do the outside lights, which I'm also going to be using one of my little QuinLED modules for. And for those lights I have selected, well, this kind of light. It's a sort of black cube, and it comes in two parts, and you can take, well, normally, let me get another one. You can take the one of the parts out, like so. And this is just a little metal box to cover stuff. And here we have the actual light. And let's hope this is sharp or in focus. It has actually two cob LEDs in it, and the idea is that you hang it from your wall like so, and the metal box will cover the screw holes, and it'll shine a light downwards and upwards, and with these little flaps you'll be able to well, basically control where the light goes. So it's been so long since I tested these lights that I don't remember the voltage. And the power supply that comes included with these is a constant current power supply. But QuinLED doesn't support constant current, because basically constant current only works if you have a driver per light. But since we want to do dimming, that's not possible, or at least not normally. So we're going to run these constant voltage, and for that I have a 24 volt power supply, because I believe they're 18 or 18.5 volts, but I don't think I can regulate this downward enough. So I'm going to be using, or testing rather, if one of these can work. I'm used to using the little DC to DC converters that's actually on the QuinLED module itself. But of course that can't sustain enough amperage, and this unit should be able to. So I'm going to take you along while I search for the voltage, and then make a test run and prepare a few modules, which I will be hooking up probably tomorrow. And that will be in part 2. So yeah, let's get testing. There's an included Allen wrench so that you can detach the light unit from the base plate when it's attached to the wall. On the base plate there is a rubber grommet to try and keep water out, and there are two clips which the little pins you turn with the Allen wrench hook into to basically pull the light unit towards the wall. Let's cut all current connections and rewire them using wire ferrules and 3-pin connector blocks, so that I can also easily splice in my multimeter to measure the current voltage. Okay, everything's hooked up. Let's splice in my multimeter and connect it to power. The video overlay is showing my socket power meter. As you can see, it's drawing about 6 watts right now, so we have a good measurement of what one of the lights should draw at maximum power, basically. Looking at the multimeter, we see that we need to approximate 18 volts. So let's take a 24 volt power supply and see how much we can regulate it down or up to, well, basically get to the 18 volts. If the 24 volt power supply can't get low enough, which I suspect, we can use the DC to DC down converter to get to the 18 volts, and let's test how that works. This is a Meanwell LRS 15024. It's capable of delivering about 6.5 amps at 24 voltage. And I choose to use Meanwell power supplies because I know they have all the official ratings needed for in my country, the Netherlands. There is a little caveat with that though, and that is that they use ceramic capacitors, which means that if you apply PWM, like we're doing with QuinLED, behind it, the capacitors can start to make a bit of noise, so be aware of that. Other than that, they're great power supplies and very reliable. I've been using a few of them for 24-hour usage for over a year now, and none of them have given me any problem or downtime, so highly recommend it. After testing, it seems that this Meanwell LRS 15024 can be regulated from 20 volts up to 30 volts. And since we need 18 volts, we'll be using the DC buck down converter to get there. And I'll put the Meanwell at around 25 volts, basically in half of its range, to hopefully get the best efficiency. I mentioned it in text earlier in the video, but if you don't have one of these automatic wire strippers, if you're going to get any tool, I can definitely recommend getting one of these because it just makes doing any project so much easier. I'll have some links to different price ranged ones in the description, so even for a few bucks you can pick one up. Okay, let's measure what the default voltage is of the DC buck down converter and set it to the 18 volts we require. there's no real reason why I'm using solid cable versus stranded cable. I just find it easier because I don't have to put ferrules on it and they fit very well in the 3-pin connectors. And I have lots of scrap pieces left over from building the house and hooking up the lights, so I just use those. Okay, success! Using the DC buck-down converter, we can power the light at 18 volts. So let's try hooking up some more lights and see if that also works. I'll again be using 3-pin connector blocks to hook up all the lights in parallel, so each light gets 18 volts. This is also the way it'll be hooked up when we connect the QuinLED module to be able to dim the lights, and how I have it set up around the house. Okay, that's all hooked up and working just fine. As you can see, it's drawing about 20 watts from the wall right now, and that's in line with what I was expecting. Hooking up the multimeter to the last part of the chain from the parallel setup, we're still seeing 18 volts, so that's good. Okay, let's splice a pre-programmed QuinLED module into the chain and see if we can dim the lights. Since QuinLED has a DC to DC converter in its own design, you can basically apply anything from 5 to 36 volts and the board will automatically function. Okay, here's the completed setup with my 24 volt power supply going into the DC buck-down converter set to 18 volts. Going into a QuinLED dimmer module, which goes into 3 lights that are in parallel. And this is me testing several different dim levels. As you can see, it seems to be working fine, and basically we've now converted these lights from having their own driver to having a central power supply and having a dim ability using QuinLED. This is the exact testing methodology I followed for all the LED lights I have in my house. So even if they come with their own driver or they are mentioned as non-dimmable, most often in this way they will work just fine. You just need to measure the voltage that you need and you can alter the setup and insert a QuinLED module to basically make any LED light a Wi-Fi controlled dimmable light. Okay, well that's it for this part. So we basically took it apart. I hooked 3 together. Then I measured the voltage using their standard constant current power supply, which came down to about 18 volts. I took a 24 volt power supply and I hooked up, well, it's still hooked up. Hold on. Okay. I hooked up this little buck-down converter circuit. I'll have a link for it in the description. It's rated for about 100 to 150 watt without cooling and about 200 watt with cooling. But they're about $4 to $5, so they're a great cost-effective solution if you need a different voltage than what your power supply can deliver. Because I was having trouble finding 18 volt power supplies, but this solution works well. So after testing it with the lights, I inserted my QuinLED board into the circuit basically, and I hooked it up to the network and I did some LED dimming, and that seemed to work fine. So the next video will be hanging these, well, I don't have one assembled right now, hanging these lights on the wall. And the way to do that is you have these little plates that come with it. And basically you screw this side of the plate to the wall and you feed the cables through this rubber grommet. You connect everything together on the inside, and then this goes in here and you use the wrench on the sides to close it up. And then you have the light assembled. You can put on the cap and it's all done. But as I said, we'll look at that tomorrow. We'll also look at hooking it up in the house, and I'll give you a sneak preview of a power board I've been working on. And yeah, so check out the next video, and that's it for now. Links in the description if you want to buy any of the components I've used. And as always, like and subscribe, and hope to see you again. Bye-bye.